So here comes the law. What is the law? What was Mr. Levaizer's statement regarding all of these experiments? So the old concept of producing or destroying matter has been abolished, has been disproved. And what is the new law here that we call law of conservation of mass or law of conservation of matter? That matter can neither be created nor be destroyed. We can't create matter, we can't destroy matter in any chemical reaction. The only thing that we can do, that we can transform matter from one form to another form. Like plant is growing. Why? Because we are giving plant what? The fertilizers, water, minerals, etc. That is why plant is able to grow. Baby is able to grow into adult because he is getting some food. So matter is converting from one form to another form, from fertilizer to plant. So conversion is there, but production is not there. Similarly, we see that the candle is burning, it is consuming, and finally it has consumed. So we thought, oh my God, matter is consuming, matter is destroying. No, that candle wax is reacting with oxygen, producing what? Carbon dioxide and water and other material. If we collect all those material, if we collect all those products, we'll get the same weight as that of the candle in the beginning. Okay? So that is why you can see on the screen its statement. In any chemical reaction, the total weight of the reactant must be equal to the total weight of the product. All right? Another example you can see on the screen. Okay, let's see further. Wait for a minute. So here in this example, you can find in the YouTube also. In one jar, there is hydrogen, the other one has oxygen. They are made to react and water is produced. You can see water vapors on glass. Okay? You will see this video with voice in your uploaded lecture. Now, let's come to the topic again. There is a scientist, Landolt. It's in our book. He performed an experiment regarding the verification of law of conservation of mass, law of conservation of matter. We have another law like this, law of conservation of energy, with the same logic. Energy can neither be created nor be destroyed in any chemical reaction. So one and the same thing. All right? So what he did, Landolt, he took a H-shaped tube. In one of the limb of H-shaped tube, he filled AgNO3, silver nitrate. AgNO3 means silver nitrate. And on in the other limb, he filled it with hydrochloric acid. Okay? AgNO3, silver nitrate plus hydrochloric acid, HCl. They exchange their partners. Silver combines with Cl, forming AgCl. H combines with nitric acid, forming HNO3. Now this is AgCl, silver chloride. This is nitric acid. Both of the reactants were transparent like water. The two limbs, silver nitrate and HCl weren't there. They were transparent. But when you mix them, AgCl and HCl3 forms. AgCl is white in color. Okay? One more thing. Before reacting it, he weighed before the reaction. He weighed it before the reaction. And after the reaction, he reweighed it. Previously, people was thinking that, oh, white thing appeared, white precipitate appeared. Precipitate means solid particles appeared. Oh, metal is forming. But later on, we can see over here that metal is not forming, it's only rearrangement there. Initially, Ag was with NO3, but now Ag has changed its partner, now it's with Cl. Now, as the composition changes, their characteristic changes, it has become white. That is why we can see it. So, before the reaction and after the reaction, there isn't any change in the weight. So, what was the reaction? He proceeded to the reaction. You can see on the screen, silver nitrate is reacting with the HCl, producing silver chloride and HNO3. All right. So what is the conclusion here? The total mass of the reactant is equal to the total mass of the product. All right. The last part. The last part. As the 20th century began, especially from the mid of the century or from the second decade of century, a lot of changes were there. So after the implementation of those changes, this law is little bit modified. You know, I told you there are two kinds of reactions. Chemical reaction, nuclear reaction. In nuclear reactions, like in atomic bomb, some higher elements like uranium breaks up, split into smaller elements, into elements with smaller atomic number, plus neutrons and energy. During these changes, it was found that very little amount of mass is converted into energy, and that energy is released in the form of radiations. So what is point to be noted over here, that mass can be converted into energy in nuclear reactions. So in such cases, the mass of the reactants is not 100% equal to the mass of the product. Where that mass goes, it converts into energy. According to Einstein's equation, you can see on the screen, E is equal to mc square, one of the most famous equations of the world. E is the energy here, m is the mass here, c is the velocity of light here. What's the velocity of light? 3 lakhs kilometers per second, 0.3 millions per second. Okay? So, if you want to find the energy in an object, for example, if I want to find the energy in a bead of 2 gram, I will put the value of m is 2, the value of c 3 into 10 to the power 8 meter per second square. We can find out this bead has such much energy. All right. So what is the point to be noted down? That in nuclear reaction, the mass of reactant is not equal to the mass of product. There's the deficiency, there's the loss of very little quantity of mass. Where that mass goes, it converts into energy according to Einstein's equation, E is equal to mc square. So with this knowledge, the law of conservation of matter can be modified as in normal chemical reactions. In normal chemical reactions, we suppose that such loss of masses could be there, but no one, not a single scientist till today is able to find that loss of mass by any sort of weighing machine. So that is why, what is the complete statement? There is no detectable gain or loss of mass in a chemical reaction.